Hey guys, today we're going to start using trig functions a little bit more than we have been already. And what we're going to do is we're doing it in terms of triangles today. So yesterday we did right triangle trig, and if you look at this, this is kind of like just a word problem for a right triangle. And so what we have here is we have from a 60-foot observation tower, so that's this lighthouse that's 60 foot tall, and then if it's 60 foot tall on this side, we know that it's also going to be 60 foot tall on this side. So from the 60-foot lighthouse on the coast, a Coast Guard officer sights a boat in distress. The angle of depression, so this angle, is 4.5 degrees. And we want to know how far the boat is from the lighthouse. So that's going to be like this distance. And then we can also apply this distance to this top piece here, and we're going to call it x. So now we have a right triangle, and we have one side, which is 60 feet. We have our angle here, which could be theta or 4.5 degrees. And we have the opposite side, and then another side that is not the hypotenuse, so that's going to be the adjacent side. So to find the side x, you're going to just use SOHCAHTOA like you've done in the past. So in this case, we're going to be using tangent because we have the opposite side and the adjacent side. So we would have the tangent of 4.5 degrees is going to be equal to the opposite side, which is 60 foot over the adjacent side. And so then we would start trying to solve this out for x. So since x is in the denominator, I'm going to go ahead and put the tan of 4.5 degrees over 1 so that we can cross multiply. And so then we would have x times the tan of 4.5 is going to equal 60. And then to solve for x, we just need to divide by the tan of 4.5 on both sides. And, sorry, I ran out of room here. So that should be 4.5. But you get the point. I'll just put like ... So we're gonna have, and I'm just gonna come down here because I ran out of room. We're gonna have x equals 60 divided by the tan of 4.5. And that's what we just solved up here. So then we're going to want to type all of this into a calculator so that we can find out basically like what the numerical answer is. So I'm going to go to my calculator, and the first thing that I want to do is make sure my calculator is in degree mode because that 4.5, that's degrees, and we need the tangent of 4.5 degrees. So I'm going to go to mode on my calculator, and the third option down is radian or degree, and make sure you put that in degree mode. And then just hit second mode to quit. And then we need 60 divided by tan 4.5. And we get 762.37. So x equals 762.37. And then it was a 60-foot observation tower, so that's going to be in feet. So even though that's kind of a tricky word problem, it's something that you should have seen in the past at some point where you can use SOHCAHTOA to solve it. But you can only use SOHCAHTOA when it's a right triangle. So what if it's not a right triangle? And so if it's not, then you can use something called the law of sines. And that's going to help you find missing sides and angles in other triangles that aren't necessarily right triangles. So this is the law of sines, and you don't have to memorize it, even though it's not super difficult to memorize. It's basically just the sides are represented by lowercase letters, and they correspond to the sine of the angle across from it. So angle A is going to correspond to the side across from angle A. Angle B is going to correspond to the side across from angle B, and that's how that's going to work out for all of them. And then it just creates a proportion. So you're going to have basically a side over the sine of the opposite angle is going to be equal to a different side over the sine of a different angle that's across from that side. So that's how the law of sines is going to work. So now we want to use that to find missing sides and angles in this triangle. So it tells us that angle C is 102.3 degrees and angle B is 28.7 degrees. And then the only other thing we have is that side B, which is going to be across from angle B, is 27.4 feet. And so we need to find side little a, side little c, and angle A. So starting with angle A, that should be pretty simple because we have a triangle and we have the other two angles in it. And so we know that angle sums in a triangle are going to add up to 180. So we're going to have the angle A is just going to be 180 minus those other two angles. So minus 102.3 and minus 28.7. So when I calculate that, the amount left for angle A is going to be 49 degrees. So angle A is going to be 49 degrees. And so then I just need to find side little a and side little c. So let's start with side little a. So we're going to have side little a over sine of angle A, which is 49. And we're going to set that equal to side little b, which is 27.4, over the sine of angle B, which is 28.7. And so then to solve for A, you're basically just going to have to cross multiply. So we're going to have A times the sine of 28.7, and that's going to equal 27.4 times the sine of 49. And then I still wouldn't evaluate any of this yet because you don't want to round too much. So before you type anything in, I would go ahead and solve for A in terms of the sine of the angles. So I'm going to go ahead and divide by the sine of 28.7. And so then you're going to have little a is going to equal 27.4 times the sine of 49 divided by the sine of 28.7. And so you're going to want to put all of that into your calculator. So I'm going to get my fraction bar in, and I'm going to do 27.4 times the sine of 49, and then that's divided by the sine of 28.7. And I would get 43.06 for side little a. And so that was 43.06. So now the last thing you need to find is side little c. So we're going to have side little c divided by the sine of angle C, which is 102.3. And that's going to be equal to, and even though we have side little a now, we're not going to want to use that because this 43.06, that's a rounded number. So I'm going to stick to side little b and angle b because we were given that originally. So we know that those are the exact measurements of that side and angle. So first I need side little b, which is 27.4, divided by the sine of angle b again, which is 28.7. And so then we're going to cross multiply on this one as well. So we're going to have c times the sine of 28.7 is going to be equal to 27.4 times the sine of 102.3. 102.3. There we go. And so then we're going to need to divide by the sine of 28.7 on both sides. And what we're going to end up with is little c is going to equal 27.4 times the sine of 102.3 divided by the sine of 28.7, and you're going to evaluate that. And what you should end up with is 55.75. And that's going to give you all of your missing sides and angles on this triangle. But then sometimes you aren't given enough information to be able to use the law of sines. So in these cases, it's going to be when you're given 3 sides of the triangle, or you're given 2 sides and an angle, but the angle you're given is between the 2 sides, so you don't know what the opposite side is. So that's going to be like the side angle side case. In these 2 cases, you can't use the law of sines because there's not enough information. So when that happens, you're going to have to use the law of cosines. So this whole formula, it looks a little bit intimidating, but it's actually not too bad. So basically, you're going to have side little a squared is going to be equal to side little b squared plus side little c squared minus 2 times bc, or sides little b and little c, times the cosine of angle A. So, and then this works as well, like if you switch around the letters, basically whatever side squared you have first is going to correspond with the angle across from it, and you're going to use that angle for the cosine. And then B and C are just going to be the 2 other sides that you have. So we're going to do a couple of examples using the law of cosines. So this example is an example of the side, side, side case where we have all 3 sides and we need to find the angles. So just a general rule for this is you're going to want to start by finding the angle across from the longest side. So in this triangle, the longest side is going to be side little b. So the first angle we're going to want to find is angle B. So we're going to start with little b squared. So here's just like, I'm going to write out the formula for whenever you're finding little b. So it'd be like little b squared is equal to a squared plus c squared minus 2ac times the cosine of angle B. So you just kind of like switch the letters around so that you have the formula how you need it. So we're going to start with little b squared, so that's 19 squared. And that's going to be equal to little a squared, so that's 8 squared, plus little c squared, so that's 14 squared, minus 2 times little a, which is 8, times little c, which is 14, times the cosine of angle B, which is what we're looking for. So then we're going to keep going until we can solve for B. So right now we have 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of B. So all of this, the negative 2 times 8 times 14 times the cosine of B, is currently chunked together because it's being multiplied. So starting and trying to get cosine of B by itself, I'm going to subtract my 8 squared and my 14 squared to the other side. So what I'm going to do is I'm just going to type in 19 squared minus 8 squared minus 14 squared. And I'll end up getting 101. So on this other side, I'm going to have 101 is going to be equal to negative 2 times 8 times 14 times the cosine of B. So then I can get rid of the coefficient in front of the cosine of B. So I'm going to just go ahead and simplify out what is negative 2 times 8 times 14. So we have negative 2 times 8 times 14, and that gives us negative 224. So we have 101 equals negative 224 times the cosine of b. So now I want to go ahead and divide by negative 224. And I would have 101 divided by negative 224. And let's see what that is. It'll give us negative 0.45089. I'm going to put negative 0.45 ... to indicate that I still want to go back and use that whole number. And then that's going to equal the cosine of angle B. So if you guys remember from past math classes, if you have the cosine of a variable and you don't know what's inside and it's equal to a number on the other side, the way that you're going to solve for that is by taking the inverse cosine. So we're going to take inverse cosine of that number on the other side, so the negative 0.45 number. And then that's going to give us what angle B actually is. So coming back to our calculator, to get inverse cosine, you're going to hit second, and then you're going to hit the cosine button. And then I want the cosine of that number, that negative 0.45 number, and then I'm going to press enter. And so then that's going to give me angle B finally, and it is 116.800. So I'm just going to call it 116.8. And I'll label that in my triangle. So now that we've done all of that work to find our biggest angle, we can, if you want to, you can use the law of cosines to find your second angle. But now we have enough information that if you wanted to use the law of sines, you could do that as well. So say that I want to find angle A. Then I would have side little a, which is 8, divided by the sine of angle A, which is what we're looking for. And then that would be equal to side little b, which is 19, divided by the 116.8 number that we had a minute ago. And so now we can cross multiply here and get 19 times the sine of A is going to be equal to the 116.8 times 8. So I'm going to pull my calculator back up. Since I still have it in here, I'm just going to scroll up and use that whole number. So 116.8009. And then I just want to multiply that by 8. And I get 934.407. So, and then I'm still going to write ... because I'm still going to go back up and use the whole number. So now I need to divide both sides by 19. And I would get the sine of angle A is going to be equal to the 934 number divided by 19. So I'm just going to hit divided by 19. And I get 49.179. And now I need to take the inverse sine to find angle A. So A is going to equal inverse sine of 49.179. And coming back to my calculator, to get inverse sine, I'm going to hit second sine. And I need it of this number up here. So the inverse sine of that, I got an error. So let me go back and see what happened here. Okay, so up here, I messed up. I put 116.8. It's supposed to be the sine of 116.8. So then I had 19 times sine A, and it wouldn't be 8 times 116.8. It would be 8 times the sine of 116.8. So let's get that out of there. And then that's going to change this number as well. So that's a quick, easy fix though. We're just going to come back to our calculator and up here where we had the 116.8, I actually am going to need the sine of that number. So I'm still going to just scroll back up and grab it. So the sine of the 116 and then times 8. And I'm going to get 7.14 instead of the very large number that we had earlier. So let me come back here. And this should have been 7.14. And then that would be divided by 19. So divided by 19 is going to give us 0.3758. And that looks like a more reasonable number to get an inverse sine for. So now I'm going to hit second sine 0.37. Well, I'm not going to type in the number. I'm going to scroll back up and get it. So inverse sine of 0.3758 is going to give us 22.075. So A is going to be 22.075. And you can put that in here for angle A as well. And so then now we have 2 out of 3 angles in our triangle. So to find our last angle, all we have to do is subtract out the first 2 from 180. So we would have 180 minus 22.075 that we just found. And then minus the 116.8 that we had earlier. And our last angle would be 41.125 degrees. And so finding that last angle, you can always just subtract the other 2 from 180, and that'll find it for you. So just be careful whenever you're starting out with these. Make sure you always put the sine with the angles and stuff like that. That's a very easy mistake to make. So I'm not going to take it out of the video whenever I make the mistake, because I need you guys to pay attention and make sure that you don't make the same mistake. Okay, so this is going to be our last example, and it should definitely go through quicker than our previous ones, because all we want to find this time is side A. So to find side A, I have A squared is going to be equal to B squared, so that's going to be 15 squared, plus C squared, which is 10, and then minus 2 times side little b, which is 15, times side little c, which is 10, times the cosine of angle A, which is 115 degrees. So in this one, all of this right-hand side here is just going to be a number. So I'm going to have A squared is going to be equal to that number. So I'm going to go ahead and calculate what that whole thing is. So I have 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of angle A, which is 115. And I'm going to hit enter, and I get 451.785 ... And so the last thing that I need is to take the square root so that I can solve for A. So to do that, I'm going to hit second x squared and second answer so that I can get that previous number in there. And I would get A is going to be 21.255. And that is all for whenever you have the side angle side case. And then you can also find the other 2 angles. And at that point, you should have enough information to be able to use the law of sines to find the other 2 angles. So that is about all for the law of sines and cosines.